We now have the ability to compute the center of a lamina. However, what about a scenario in which my lamina is described by the region bounded between the graph's two equations, y equals f of x, y equals g of x, as x ranged from here to here? Because moments are defined in terms of sums, we have additivity properties, and clearly it's the case that I would just simply subtract off the outputs of my functions. Or you can interpret this as looking at the area of the rectangle, just like I did in the last video, and come to this conclusion. If indeed I'm bounded above and below by the graphs of these two equations, here's x bar. It's nothing more than what I have up here, with something subtracted from the f of x, namely this. Same thing happens here. So let's put it to practice. So consider this region here bounded by the graphs of these equations. Let's compute the centroid. First things first, I'll cover the area. I think I take that back. I don't think this is going to work with the amount of space I have. Can I rephrase that? Not changing anything I said. Shoot. More board space issues. Now that I have it, let me just remind myself over here, because I need that board space. Looks good. So for that centroid, or shall I say, for that center of mass, at one point that bounds out the entire lamina, I will next compute x bar, excuse me, and then y bar. But of course, x bar is going to look like this. And y bar is simply going to require just a tad bit more room. I'll come down here. And in particular, by the way, looking over there, there's a negative sign missing, isn't there? Do you mind if I stop? I set up the intervals. I like it.